Hello viewers. Today we will discuss one of the most happening thing in computing world, that is network security. We will discuss what is network security, why we need network security and general network security mechanisms. Security is a broad topic and covers a multitude of sins. In its simplest form, it is concerned with making sure that nosy people cannot read or worse yet secretly modify messages intended for other recipients. It is concerned with people trying to access remote services that they are not authorized to use. Security also deals with the problem of legitimate messages being captured and replayed, and with people trying to deny that they sent certain messages. Now question arises that computer networks have been in existence for so many years. So why so much hue and cry about security now? So answer to this is that over the past few years, number of services being provided through internet has increased many times. So is the threat to these services and related data. Such applications like e-banking, online ticket reservation, management information systems require mission critical networks that accommodate voice, video and data traffic, and these networks must be scalable to support increasing number of users and need for greater capacity and performance. However, as networks enable more and more applications and are available to more and more users, they become even more vulnerable to a wider range of security threats. To combat these threats and ensure that e-business transactions are not compromised, network security plays a major role in today's networks. Main goal of security are as shown on the screen are confidentiality, integrity and availability. Confidentiality is probably the most common aspect of information security. We need to protect our confidential information. An organization needs to guard against those malicious actions that endanger the confidentiality of its information. Confidentiality not only applies to the storage of information, it also applies to the transmission of information. When we send a piece of information to be stored in a remote computer, or when we retrieve a piece of information from a remote computer, we need to conceal it during transmission. Integrity implies that updations to stored data must be made only by authorized entities and through authorized mechanisms. Integrity violation is not necessarily the result of malicious act. An interruption in the system, such as power surge, may also create unwanted changes in some information. The third component of network security is availability. The information created and stored by an organization needs to be available to authorized entities. Information is useless if it is not available. So information needs to be constantly changed, which means it must be accessible to authorized entities. The unavailability of information is just as harmful for an organization as the lack of confidentiality or integrity. Imagine what would happen to a bank if the customer could not access their accounts for transactions. These three aspects of security, that is confidentiality, integrity and availability, are violated because of security attacks. So now what is security attack? Any action that compromises the security of information owned by an organization is called security attack. Now two things are to be considered separately in context of security attack. These are threat and attack. Let us first understand the meaning of threat. Threat is a potential for violation of security which exists when there is a circumstance, capability, action or event that could breach security and cause harm. That is, a threat is a possible danger that might exploit vulnerability. Then what is attack? Attack is a deliberate attempt, especially in the sense of method or technique, to evade security services and violate the security policy of a system. Security attacks can be of two types: passive attacks and active attacks. Passive attacks. Passive attacks are in nature of eavesdropping on or monitoring of transmission. The goal of opponent is to obtain information that is being transmitted. Two types of passive attacks are release of message content and traffic analysis. The release of message content is easily understood. A telephone conversation, an electronic mail message, and a transferred file may contain sensitive or confidential information. We would like to prevent an opponent from learning the contents of these transmissions. The figure on the screen reveals the concept of eavesdropping. In this figure, two fictitious persons, Bob and Alice, are communicating through internet or other communication facility. Darth, the third person, is reading contents of message by listening to the communication channel. A second type of passive attack is traffic analysis. Suppose that we had a way of masking the contents of messages or other information traffic so that opponents, even if they captured the message, could not extract the information from the message. The common technique for masking content is encryption. If we had encryption protection in place, an opponent might still be able to observe the pattern of these messages. The opponent could determine the location and identity of communicating hosts and could observe the frequency and length of messages being exchanged. This information might be useful in guessing the nature of communication that was taking place. The figure on the screen reveals the concept of traffic analysis. In this figure, Bob is sending messages to Alice in an encoded form. These cannot be understood by Darth, but still Darth is able to observe pattern of communication, hence there is loss of confidentiality. Second category of attack is active attacks. Active attacks involve some modification of the data stream or the creation of a false stream and can be subdivided into four categories. These are masquerade, replay, modification of messages, and denial of service. A masquerade takes place when one entity pretends to be a different entity. A masquerade attack usually includes one of the other forms of active attack. For example, authentication sequence can be captured and replayed after a valid authentication sequence has taken place, thus enabling an authorized entity with few privileges to obtain extra privileges by impersonating an entity that has those privileges. The figure shown on the screen represents the concept of masquerading. In this figure, message authentication sequence sent by Bob to Alice has been captured by Darth. So it appears to Alice as if she is communicating with Bob. It is a serious security breach as Darth is pretending to be Bob. Now, replay involves the passive capture of a data unit and its subsequent retransmission to produce an unauthorized effect, as shown in figure on the screen. In this type of attack, messages are captured by Darth and later replayed to Alice. Modification of messages simply means that some portion of a legitimate message is altered or that message are delayed or reordered to produce an unauthorized effect. For example, a message meaning allow John Smith to read confidential file account is modified to mean allow Fred Brown to read confidential file accounts. Concept is shown on the screen. As shown in the figure, message is captured by Darth and modified. After modification, the message is sent to Alice to get unauthorized access. Another serious kind of attack called the denial of service prevents or inhibits the normal use or management of communication facilities. This attack may have a specific target. For example, an entity may suppress all messages directed to a particular destination. Another form of service denial is the disruption of an entire network, either by disabling the network or by overloading it with messages so as to degrade performance. The concept is shown on the screen. In this figure, Bob, a legitimate user, is trying to get some service from the server, but Darth has overloaded the server by redundant requests, thus preventing the legitimate user, Bob, from using the service. All the attacks described up to here can be classified with respect to security properties of confidentiality, integrity, availability as shown in figure on the screen. Eavesdropping and traffic analysis are threat to confidentiality. Modification, masquerading, replaying and repudiation are threat to integrity, and denial of service is threat to availability. So, viewers, after being armed with knowledge of different type of attacks, let us know something about techniques used for network security. Network security and information security are two overlapping issues. Violation of network security leads to violation of information security and vice versa. So, we will first discuss two techniques of information security which are used as network security services. First one is steganography and other is cryptography. Now, let us discuss these two techniques in detail. Steganography is a technique that was used for secret communication in the past and is being revived at the present time. The word steganography with origin in Greek means covered writing, in contrast with cryptography, which means secret writing. Cryptography means concealing the contents of a message by enciphering, that is encoding. Steganography means concealing the message itself by covering it with something else. The steganography can be used by writing hidden text in a picture or anything else. We will mainly discuss cryptography here. Cryptography, as already told, a word with Greek origin means secret writing. However, we use the term to refer to the science and art of transforming messages to make them secure and immune to attacks. Although in the past cryptography referred only to the encryption and decryption of messages using secret keys, it is defined as involving three distinct mechanisms: symmetric key encipherment, asymmetric key encipherment and hashing. Let us discuss symmetric key encipherment. Symmetric key encipherment is also known as traditional cipher. In symmetric key encipherment, same key is used for encryption and decryption, and the key can be used for bidirectional communication. The figure on screen represents the general concept of symmetric cryptography. As shown in the figure, Alice and Bob are communicating. The message to be transmitted from sender is known as plain text. It is converted into ciphertext using encryption algorithm and shared secret key. The secret key is shared through some channel other than secure channel. The ciphertext or encoded text is transmitted through insecure channel. At the receiver, the end ciphertext is decrypted using decryption algorithm and shared secret key. We refer to encryption and decryption algorithms as ciphers. So, now please notice that the key used for encryption and decryption is same. A key is a set of values that the cipher as an algorithm operates on. In addition, the encryption and decryption algorithms are inverse of each other. That is why technique is known as symmetric key encipherment. Symmetric key encipherment is also called secret key encryption or private key encryption. Encryption can be thought of as locking the message in a box. Decryption can be thought of as unlocking the box. In symmetric key encipherment, the same key locks and unlocks. Key is basically a method to encrypt and reverse method is used to decrypt. Substitutional ciphers. We can divide traditional symmetric key ciphers into two broad categories: substitution ciphers and transpositional ciphers. A substitution cipher replaces one symbol with another. If the symbol in plain text are alphabetic character, we replace one character with another. For example, we can replace letter A with letter D and letter T with letter Z, etc. There are another type of cipher known as transposition ciphers. A transposition cipher does not substitute one symbol for another. Instead, it changes the location of symbols. A symbol in the first position of the plain text may appear in the 10th position of the ciphertext. A symbol in 8th position in the plain text may appear in the first position of the ciphertext. In other words, a transpositional cipher reorders the symbols. After having a brief introduction to symmetric key in cipher, now we will discuss asymmetric key ciphers. Asymmetric cryptography uses two separate keys, one private and one public. If encryption and decryption are thought of as locking and unlocking locks with keys, then a lock that is locked with a public key can be unlocked only with the corresponding private key and vice versa. Figure on the screen shows that if Alice locks the lock with Bob's public key, then only Bob's private key can unlock it. Now, apart from requirement that information must be transmitted in a secure way in a network, another requirement is to ensure the integrity. For this purpose, hash functions are used. In this technique, special kind of cryptographic hash functions are used. Hash functions take a message of arbitrary length and create a message digest of a string of fixed length. Whenever there is even a slight alteration in the message, it can be detected by computing message digest again. Suppose receiver of a message wants to be sure that messages received by him is unaltered. For this, sender may calculate message digest. This message digest is passed to receiver through some other channel. Receiver may calculate message digest again. If two message digests match, receiver may be sure that no alteration has taken place. Several hash algorithms were designed by Ron Rivest. These are referred to as MD2, MD4 and MD5, where MD stands for message digest. Another technique used for network security is digital signature. A digital signature uses a pair of private public keys. We are all familiar with the concept of a signature. A person signs a document to show that it originated from her or was approved by her. The signature is proof to the recipient that the document comes from the correct entity. When a consumer signs a check, the bank needs to be sure that check is issued by that customer and nobody else. In other words, signature on a document, when verified, is a sign of authentication. The document is authentic. Similar technique employed in computer networks is called digital signature. When Alice sends a message to Bob, Bob needs to check the authenticity of the sender. He needs to be sure that the message comes from Alice and not the Eve. Bob can ask Alice to sign the message electronically. In other words, an electronic signature can prove the authenticity of Alice as the sender of message. Now, let us move on to network security hardware and software solutions. When we think about network security, we think about boundary in which our network is established. We need to protect our network from external attacks, and we also need to monitor internal suspicious activities. We usually deploy security devices to protect our network like border router as static filtering device, firewalls, intrusion detection systems and intrusion prevention systems. Routers are the traffic cops of the network. They direct traffic into and out of and within our networks. The border router is the last router you control before an untrusted network such as the internet. Because all of the internet traffic goes through this router, it often functions as the network's first and last line of defense through initial and final filtering. We can configure border router as static packet filtering device by configuring access control lists. We called router as static filtering device because it can inspect packet only up to layer 3, that is network layer. Another network security solution, which may be in form of hardware or software, is firewall. A firewall is a checkpoint device that has a set of rules specifying what traffic it will allow or deny to pass through it. Firewalls come in several different types. We will be discussing firewall in detail in the coming sessions. Although firewalls aren't perfect, they do block what we tell them to block and allow what we tell them to pass through. An advanced network security solution is intrusion detection system. An IDS is like a security alarm system for your network. that is used to detect and alert on malicious events. The system might compromise many different IDS sensors placed at strategic points in your network. In general, IDS sensors watch for predefined signatures of malicious events, and they might perform statistical and anomaly analysis. When IDS sensor detects suspicious events, they can alert in several different ways, including email, paging, or simply logging the occurrences. Intrusion prevention system. An IPS is a system that automatically detects and prevents network and host attack. In contrast to a traditional IDS, which focuses on notifying the administrator of anomalies, an IPS strives to automatically defend the target without the administrator's direct involvement. Such protection may involve using signature-based or behavioral techniques to identify an attack and then blocking the malicious traffic or system call before it causes harm. In this respect, an IPS combines the functionality of firewall and IDS to offer a solution that automatically blocks offending actions as soon as it defends an attack. So viewers, in this program, I have tried to explain to you about common terms used in field of network security and information security. We have covered concepts of confidentiality, integrity, availability, cryptography, message digest, intrusion detection system, intrusion prevention system. I hope introductory knowledge about these concepts will help you to learn advanced concepts of network security. Thank you.